All right, hello everybody. We are now in session 9 of our data science masterclass. What we've done in the past session was we've gone into the association part of unsupervised learning, and so we took the retail data set last time that was in transaction mode, and then we tried to figure out which items can be bundled together, right? And so what we're going to do this time is we're going to take a movies data set, different types of data from movies, and we're trying to see if we can make some recommendations based on that. Okay, so let's first start by loading the data, and then we'll go into kind of what we're trying to do here. Okay, so start with initializing the data here. Let's just start with pandas. We might need a few more libraries. Okay, let me bring in NumPy as well. All right, so let's just go with those for now. And then when it comes to data, this time we have two different data sets, and I'll show you what those are. So one is the movies itself. So within the movies folder, we have two data sets. Movies metadata. Movies metadata. It says clean because, as I was preparing the data, it remove a lot of the issues with the data. There's a lot of data offsetting and things like that, which is something that you guys also might have to do at some point in time. We'll talk about that later, but for now, let's just assume that it is somewhat cleaned. Right. So here's one data set, and then now let's see this one first, and then we'll go to the next one. So here we're seeing that every row in this table, see here, the movie here is Toy Story, and there's what's the budget for this. Here's an overview of what the movie is about, and then there's when it was released, how long, and then there's a tagline, a 1 sentence or 2 sentence tagline, and so there's vote count here, but this is really an aggregate of maybe from Rotten Tomatoes or something like that. But there's only one row per movie, or there's supposed to be one row per movie, and so you see the next movie here is Jumanji and Grumpier Old Men, blah blah blah, right? So you have one row for every movie, and you're really getting some metadata about each movie. Okay. So by the way, this data set is a very popular data set, and there's a lot of insights you would be able to derive from this, right? There's time, so you could do some kind of time series analysis. You could do size of the movies. There's some and you could do a lot of text mining on the movies itself, on the descriptions, because there's a lot of text data, free-form text. But anyway, what we are going to try to answer today is this question of, can you recommend movies that users may like? Okay. All right. So this is one data set, and then let's also load the other data set here. Let's call it the movies. And this movie is called movies _ratings small. So let's see what's in here. this is purely movie ratings. So we don't even know what the movie is. We just have some kind of movie ID. We have some kind of user ID. So the way you read this is that user one uh, thinks that movie 31 or likes movie 31 with a rating of 2.5. And then the same user for movie ID 1029 has given it a rating of 3, and then this user 1172 has given a rating of 4 for this movie. User 1, movie 1172. So if we had, let's go to the tail just to kind of see. Okay, so you have another user here, and then all the movies they have watched and what ratings they've given. Right? So you see that this is two different, very different types of data. One data set here has a lot of metadata about the movies, but not so much about whether you as a user like it or not. And here there's another data set which tells you all about whether a user would like a movie, whether a user liked the movie, but you don't exactly know what the movie is. Okay, so let's now go off into our notebook just to try to understand. So I want, because last time, remember, we had transactional data, right? We have transactional data, and we were trying to bundle items that go together. This time we have two different data sets. So typically when you try to do an analysis like this, right, it ends up being somewhat, what I've noticed is it is somewhat confusing when you try to do a web search to try to solve this this problem. And the reason for that is that a lot of these are all grouped together, and there's a lot of terminology and there's a lot of mismatched application of algorithms. Okay, so what we're going to try to do here is clarify that, and hopefully this summary or this overview would help with that. Okay, so I'm going to give you a few different cases. So let's say that so here's an item I am interested in. Okay, so I am interested in some item. So let's say I am interested in, so I'm searching for, let's say a Surface Pro, okay? I'm searching for a Surface Pro. So I got my Surface Pro here. Draw my little pen there because that's what I need. Okay. So I am interested in this Surface Pro. So I'm searching for it, for example, on some site. And the question I want answered is, what are other similar items? Okay, that's my question. So this is kind of one area. Okay, and so maybe maybe as I am searching for Surface Pro, I might also be shown maybe I might be shown a MacBook Pro because it has a lot of similar kind of, if you look at the description of a Surface Pro and you look at the description of MacBook Pro, there might be a lot of commonality there. Or it might also show an iPad Pro, right, with a pen, because that gives me something to write with, and it might show me the iPad Pro. Okay, so it might give me these types of recommendations here on the right, given that I was searching for the Surface Pro. So this is based on the textual descriptions, right? So there's a description of the Surface Pro, which it has a lot of commonality with the description of the MacBook Pro, which has a lot of commonality with the description of the iPad Pro. And so um, uh, that's how these are being generated. Okay, these recommendations. Now, suppose I have already placed a Surface Pro in my shopping cart. Okay, so I've already done this, and now I wanna know what other items go with it. Okay, what else do people buy along with that typically? Okay, so you see, this first one is I haven't done anything. I'm just searching, finding. Now I've actually placed it in my cart. Okay, so now I've got my Surface Pro. I've already Surface Pro, and it is in my little shopping cart now. Okay, that's my little shopping cart icon. It's got a 1 on it because I've put it in my shopping cart. And now what I want to know what other goes with it. So we'll say, oh, you know what? You should add a if it's a Surface Pro, you're really gonna want the stylus that goes with it, because that's kind of what it's all about. And you might also want to get a docking station, for example, or a little docking hub. So you might want to get those items as well. Right? This is the bundling recommendation. So this was the bundling recommendation, and we did this last time, right? This is the bundling recommendation. Okay. All right. And then next, let's say that I've already purchased. Okay. So now I have already purchased a Surface Pro in the past, and I really liked it. Okay, and so now the question is, what else might I like? So I've already purchased a Surface Pro, right? Okay, so now I'm gonna say that my Surface Pro has already been purchased, and I have given it a 4.5 star rating, and so this is a 4.5 star rating. Now, what else might I like? Okay, so it might come back and say, hey, you know what? People who liked the Surface Pro, also happened to like these Bluetooth headphones. Okay, so what I want to call out here is, you see these different types of recommendations. Okay, the second one here is what we did last time, and we called that the bundling recommendation, right? The one up here, the first one, I'm interested in something. What are other similar items, right? Here, the way it works is you have multiple items, right? You have the description of the MacBook Pro, you have the description of the iPad, you have the description of many, many, many items. And so what it looks for is a commonality between items. Okay, so it looks for commonality between item descriptions. Okay, it looks for other items with similar descriptions to what you are searching for, and then suggests that to you. Okay, so you're searching for some item here, and it looks for another item that has a lot of commonality in the description, and then makes that a suggestion. Okay, so because it is based on the content of the description, right, between the description content, this is known as content-based filtering. So I'm filtering all the remaining items based on their content, description, tagline, etc., and then bringing the top few and then showing them to you. All right. But here, down here, I have already purchased a Surface Pro in the past. What else might I like? So it's unlikely that a person who purchased a Surface Pro is now going to go and purchase an iPad Pro or a MacBook Pro, right? Because they've already purchased what they wanted. They already have they're already using it. So now you can still provide some other types of recommendations. So let's say that this is me, and I have purchased this Surface Pro, and I really liked it. Okay. Again, key thing is here is that we need some information whether we liked it or not. All right. So I really liked this item, and in the past I have also purchased, let's say, a Wi-Fi extender, which I just did, by the way, to increase the network in the basement I'm at. But so I had to, and I reasonably like it also, and so on and so forth. So I have these products, and then there's somebody else, all right, who has purchased a Surface Pro, and they like the Surface Pro, and they have maybe they've purchased a new Raspberry Pi or something, right? A new device for streaming, a streaming device, and they really like that also. And so what we would do here is that we would look for commonality between people. Okay, so we're looking for commonality between, or users, let's just call it users, between users. Okay, and if we see that, hey, you really like this item and somebody else also liked this item, and of course it won't be only one item, suppose we both also liked some other item, that it would we would essentially say that, me and this other person, we're similar, so there's this other item that this person liked, you might also like it. Okay, so it would essentially be creating this mapping and then saying, oh, you know what, and then of course it would go to the other person and say, hey, maybe you also need a Wi-Fi extender, right? So because this is making recommendations based on the commonality between users, that's why this is called collaborative filtering, because it is filtering other users based on how, what is the collaborative nature of us as users, and then making recommendations based on that. Okay, so these are the major areas, right? And of course, what we did last time was the second one, the bundling recommendations. If you remember, we are looking at transactional data there, right? And then we know that invoice a specific invoice. What did people buy? Item. Maybe somebody bought a Surface Pro and they also bought a stylus, and somebody in another transaction somebody bought a Surface Pro and a stylus, and that is how we kind of bundled them together, right? So you see that even though they all look very so, and by the way, all of this it falls under association, but these are typically called recommender systems. So when you go and try to look for recommender systems, things are all really convoluted out on the internet. All of these are just completely mixed up, right? So what I really want to call out today is if you're just searching for an item and we don't really know anything else about that user, we don't know what else they have bought in the past, we don't know what they like. This is it's called a cold start problem. You don't know anything, but they're just searching for something. You can apply content-based filtering to go and find the similar items because you already have these other items in their descriptions, right? You can go and say, hey, you know what, maybe you should also look at these other ones because you might want to consider that instead of what you're going to buy. Then next step is, okay, you put it into your cart. Then if we have transactional data like this on other users and what else they put in their cart at the same time, then you'd be able to apply the bundling recommendation. If you guys remember last time, that is also called association rule mining, also called market basket analysis, blah, 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 right? To give you what else would be bundled well together. And the point is here, you should buy them at the same time, because if you have a Surface Pro and you didn't get the stylus, well, then you just got a basic laptop essentially, right? Okay, but then now let's say you already purchased the item, you already like the item, you have additional information about likes, right? You know how many stars, how many ratings, whatever somebody has given, then you'd be able to apply, then you'd be able to say, okay, other people like you who liked similar items also like this other item that you've never tried, so maybe you should consider trying it. Okay, all of this is usually mixed up all together, but I want you guys to know how these are different and when you should apply what. Okay, so last time we already applied the bundling recommendation here in the middle, so we're not going to do that today. Today we're going to try to do this first and the third one, so the content-based filtering and the collaborative filtering for movies. Okay, all right, so let us now but how do we do that? Let's go down a little bit now. So how do we do that? So now we're talking about content-based filtering, okay? And let's take an example here. So content-based filtering again is the first one here, which means we need descriptions. So suppose we had, we could do this in Excel as well, but maybe I'll just, in the interest of time, do it, try to do it here. Okay, so suppose we have movie description, okay? So let's say here's a description of movie 1, okay? M1, the best Italian movie, enjoy the best mafia. Okay, so this is some combination of descriptions that you just put together, grouped it together, and then you've got movie number 2 is some sort of American movie, so it says American movie, enjoy the best sitcom, and then Korean movie, enjoy the best horror. The best horror, and then, by the way, there's a reason I'm writing all of this down. We wouldn't waste time writing it otherwise. And then again, you see sometimes when you bring all of this together, there's going to be a repetition. So the best American movie. Okay, so the whole point here is to how do you deal with unstructured or open free form text that either somebody has typed up, or think of these as what people have described the movie as, and all of that. Okay, so you got descriptions for every movie, and so now we want to find out. Our objective is to find out which movie is similar to which other movie. Okay, and so we want to make this collaborative. All right. So suppose somebody was thinking about this, a movie one, the best, whatever this best Italian movie is. What else would we recommend? So they haven't watched it yet. They're just searching for it. But then, or what else would we say that is very similar to this movie based on this description? So let's do this. Let's say that we want to use the description, right? So let's list out all the different words that have been used. Okay, so you've got the word. So you got Italian, then movie, enjoy, the best, mafia, American sitcom, Korean, and horror, right? Okay. So these are all the terms that have been used in all of these movies, okay? And now, so we're just going to count the number of times this word shows up in this, okay? So the word Italian shows up one time in this movie, and out of how many? Out of 8 words, okay? 1 out of 8. The word Italian doesn't show up anywhere here out of 6 words. Doesn't show up anywhere here out of 6 words. Doesn't show up anywhere here out of 6 words. Okay, and then let's do movie. Okay, the word movie shows up 1 out of 8, 1 out of 6. It shows up here. It shows up here. It shows up here. Okay, and we'll just do one more, maybe enjoy. The word enjoy, so it shows up here, shows up here, shows up here, and does not show up here. Okay, so we're essentially trying to figure out how frequently does this term show up in this document. By the way, these are called, the term used for these descriptions is document. So we are looking for the frequency of this term in this document, right? So this is also known as term frequency, or TF. Okay. All right. So it's the number of times the word occurs divided by the total number of words in this document. Okay. And so, so this gives us some idea that if I find a word, let's say in this Korean movie here, that has similar term frequencies as another, maybe my Italian movie, then I would like to give them the Italian movie and the Korean movie a high similarity index or something, right? And I can use my term frequencies here if I maybe combine it somehow. But at the same time, there's some words that show up, like the word movie, right? It shows up in all of them. So we don't really want to take in terms that show up in all of them, because these are just words that it's just going to throw our calculations off. We want to ignore them. Okay, so so if we were to calculate something in addition to that, so we have this, and then if we were to calculate the for every column, right? we want to show how many times did this word show up across all of these documents. So for example, the word Italian shows up one time out of 4 documents. The word movie shows up 4 times out of 4 documents, right? And the word enjoy shows up 3 times out of 4 documents. Okay. So this is kind of, like the document frequency now, right? Let's say document frequency. But what we want to do is we want to weight each of these terms. So we want to weight Italian, the term Italian high, and we want to weight the term movie low, right? So if we were to try to use these as weights directly, then that would be problematic because this is the opposite. This is the inverse of it, right? We want to weight this high and we want to weight the movie one low. And so let's do inverse document frequency. So if we just do the inverse of that, so you say 4/1, 4/4, and 4/3. So it's the inverse document frequency. Then we would be able to weight, yeah. So Italian gets a higher weight, the movie gets a lower weight, and then enjoy gets also a higher weight than movie. So this is good, but then we want to normalize this a little bit. Remember, we've used different types of functions in the past, so let's just do just take the log of that. Because if we take the log of this, then it would be, the log of 4/4. Or maybe I'll do this here. So let's say the log of the inverse document frequency, this is IDF, is, so this would be log 4, this is log 1, and this is log 4/3. So this would equal 0, right? And I believe this is something like 0.6. And log 4/3, let's just calculate that here real quick, is 0.125. So good. So the term Italian would get a weight of 0.6. The term movie would get a weight of 0 because it shows up everywhere. We want to throw it out. And then the term enjoy gets some weight, right? 0.125. And so on and so forth, right? So by combining this term frequency and the inverse document frequency or the log of it together, we want to create this similarity, okay? So if we were to take the combination of this row for movie 1, okay, let me do that again. If we were to take the combination of movie 1's TF for movie 1, and we were to take the IDF, and there's only one IDF, right? We take the IDF, okay, and then we take the TF of movie 3, and this, the same IDF. Then what we want to create is a matrix of movie to movie. So movie 1, movie 2, movie 3, movie 4, movie 1, movie 2, movie 3, and movie 4. And so this specific cell in this matrix, should be the similarity between movie 1 and movie 3, right? And of course this would be matrix where both of these values are the same, a mirrored matrix over the diagonal, and so both of these basically the same, which gives us the similarity between movie 1 and movie 3, and it would be a combination of the term frequency. So we want term frequency of so you got term frequency of movie 1 times the IDF, right? This is what gives me the value for movie 1, and then I want to multiply that by the term frequency for movie 3 times the inverse document frequency for movie 3, right? So if we were to do that multiplication, we would get the value that should go in that matrix. But it would also be nice to normalize this value. So in order to, let's say that we want this matrix to be somewhat standard so that the diagonal is just a value of ones, right? Because if I calculate this for the same movie, then when I multiply this, it's just going to give me some number. But if I want to normalize it, then I can just divide this by let's see, divide this by sort of the TF, say the absolute value of each one of these. So I'll give you an example here. Okay, TF movie 3 times IDF. So so you see, if we were to do this for the same movie, M1 and M1, then the numerator would end up being the sum square of the numerator. The denominator would also be the same, and so we would get a value of 1. Let's do that here. So if we were doing movie 1 to movie 1, then you have TF M1 IDF times TF M1 IDF, right? Which is, this is the sum squares, right? Which is basically equal to the sum squares, TF M1 IDF, right? Square, and the denominator, because this is, remember, this is the root of the sum squares, right? And so if we do that, and then take the multiplication of that again, that also gives us TF1 IDF squared, right? And that gives us 1. So if we were to do 1 to 1, so this is purely, the denominator here is purely for normalization, okay? And so just to explain it a little bit more, let us write it out. So this is for M1, M3, this is what it would look like. Now we have a matrix of 0.25, so TF, so think of a sum product of 0.25 times 0.6 plus 0.25 times 0 plus, you see we're doing the sum product of each one of those. This would be for movie 1, and then for movie 2 we are going to be doing 0 times 0.6, right? That's here. Term frequency times 0.6 plus 1/6 times 0 plus, right? And so we go on like that. It's basically the sum product or matrix multiplication. And then here, whenever we are doing this, we are going to take the sum square, right? here. What is the, let me give you the, yeah, so you're taking the square root of the sum of squares, right? So 0.25 times 0.6 squared plus 0.25 times 0 squared, right? So you could do all of that. This is all for movie 1, and then here again you're doing 0 times 0.6 squared plus 1/6 times 0 squared, and on and on. Okay, so this basically gives us a way to calculate the similarity between movie to movie, and it just so happens that this method of calculation is known as cosine similarity. Okay, so in terms of a methodology for doing this, I know this was a long explanation, but to do content-based filtering, we are essentially going to use term frequent. We're going to use something called TF-IDF vectorization, which basically calculates the term frequency, calculates the inverse document frequency, and creates a vector out of that. And then after that, we are going to use cosine similarity to create that matrix. Okay, and then after that, once we have that matrix, whenever we have a certain movie, let's say we're somebody is interested in movie 1, then we'd be able to look at all the cosine similarities in that row, find the one with the highest cosine similarity or the top few, and then figure out what movie is the corresponding to that, and then suggest those movies. Okay. All right. So I know it's a little bit of a drawn-out explanation, but unless you see it and unless you've actually calculated it yourself, it sometimes might not be very clear. All right, so let's go ahead and actually do content-based filtering. All right, so let's just say recommendations. And today's session, I'm not going to do too much of searches because in the interest of time. And also there are specific libraries that we are going to use. Okay, so, all right, so one of this is content-based filtering. And within content-based filtering, like I said, we use the TF-IDF vectorizer. So let's say a scalar TF-IDF vectorizer. So it's inside feature extraction and text. Okay, so TF-IDF vectorizer is inside that. Let's see if there's an example here. Okay, so there's an example here. But one thing we want to also do before we do that is we want to check the data and make sure it's clean. We don't want duplicates, right? Because cosine similarity is going to get confused if you have duplicate movies, or it will just be calculating for no reason. So before that, let's go back here and do a little prepare data. And so a few things we want to look for. Remember last time we were talking about all the different steps that we would go through for pre-processing. So within, let's see what, all right, so in the movies data, so we want, first of all, we want to create that document list, right? Whatever we're going to use for the text. So we might be able to use the overview column. We might be able to use the tagline column. We can see here, if we take this text and just concatenate it, that'll give us a good document that we could use. But then we also have some missing data points here. So if it's missing, we just want to keep it empty. So to clean that a little bit, and we want to make sure that there's no duplicates in the rows. Okay, so let's do that. Let's just first see the shape. Okay, so there's 45,000 rows here, and let's see if let's just drop the duplicates and then see if it changed anything. And we want to drop duplicate. We're just looking for the title, so we don't want two movies with the same title. So we want to drop duplicates if they have the same title. And whenever you have duplicates, you get to choose which one. Again, we could have gone and searched for all of this, but I'm not doing that here. You get to decide which one you want to keep, the first one, the last one, or something. So let's just keep the first one. So if you have two movies with this exact same name, we're just going to keep the first one. And in place, okay, so if we did this and then we say, okay, so there's a lot of duplicates here, you see. There's almost 3,000 duplicates, and this is not uncommon. Whenever you have metadata type, sometimes you're pooling this from different sources, so you might have the same movie show up in multiple places. Sometimes you might actually have two movies with the same name, but we're not going to solve that problem now. Okay? All right, and then now, so here we were, say, drop duplicates, duplicate rows, or duplicate movies. And then here, now we want to prepare the description column that we're going to use for TF-IDF. So for that, let's see, we want to create, we saw that the tagline column had nulls. So we may want to use tagline and overview. So let's create a new one called description, and that should be overview, and then we'll concatenate that with tagline, and so yeah, because we don't want the word "nan" show up there, so let's do tagline and then let's say that if you have NA here, let's just fill NA with an empty. Okay, so if it's NA, let's just replace it with an empty text string, and then we'll use that here in the description. And after this, for whatever reason, if we still end up with NAs, let's replace that also with an empty, because we don't want to send any junk NA values into the TF-IDF. So we first cleaned up the tagline, then we concatenate them, and then in the concatenation we're removing any NAs again. Okay. All right. So let's see what this looks like. Okay, so it's just one long list of documents. As you remember, we basically created this list here on the left, okay? And now we are going to try to do the TF and IDF for this, so, right? Yeah, we could actually have brought both of these up there, because this prep is specific for this. So again, this is about keeping everything clean. Right. All right. So now, if we wanted to apply TF-IDF, let's say apply TF-IDF. That's where we would bring in this vectorizer, and we just created this document set. So let's go ahead and do that. So it's in sklearn feature extraction, and we have our data frame here. So we just need to do a fit transform. Okay, so this is as far as we need. So let's take this. So this is to generate, so let's just say what we're doing here. We're trying to generate a matrix of common terms, right? Terms using the description. Okay, all right, so we already have our description column, so we will use that. And just for standardization, let's call this model TF vectorizer for movies. TF IDF vectorizer, okay, and then movies for transform, and then we'll give it this description column. That's what we want to use here as our document. And this is basically taking this and creating that. It's first creating the TF IDF matrix. Okay, so it is the multiplication of the TF and the IDF in one matrix like this. And so that's why let me call this. Let's call this the TF IDF matrix, and we're going to use that TF IDF matrix next. So let's just see what the shape is. Okay, so this is now creating that matrix, and you see the number of rows is the same as the number of rows here, because you have one row for every matrix, and we're just and there's 75,746 terms. Right? Here we had whatever we had. 10 terms. Over there we have 75,000 terms, and now we want to calculate the cosine similarity matrix. Okay. All right, so we're gonna have to speed up a little bit here. Let's learn cosine similarity. So it's under metrics pairwise cosine similarity. So this is, you see here, we said the cosine similarity of two vectors x and y is the multiplication divided by the normalized dot product. So let's bring this here. Okay. Let's see, from sklearn.metrics.pairwise import cosine similarity, and then we can call this cosine sim, and so cosine similarity, and we want to give it the TF-IDF matrix, okay, that we just created. That's what's going in. It already knows to take every row in there. So this should create a 42,000 by 42,000 matrix, right? Because it's movie to movie. And cosine similarity can be used for many things. So here we're going to give x and y, which is what you want to get the similarity for. We're going to give the same matrix so that you get a 42,000 by 42,000. And this just helps when it is sparse. We don't need that here. Okay, this might take a little time because it is doing this for multiple ones. So let's see. Yeah, so while this is running, maybe we'll go. Actually, let me do one more thing here before we jump off. So when I start running, this is going to take a little time. So what we want to do next is let us go ahead and create the code we're going to use to, let's say we have this cosine similarity matrix. How are we going to use it? Remember I said that once we have this, for any movie, we give a movie in, we want to know which movies are the most similar. But that means we have to look at this movie, find all the cosine similarities for that movie. Then we want to sort them without losing the index of the movies. We want to sort them. Then based on that index, we want to go and find out which movies they are, right? So this requires a little bit of code. So let's go ahead and write that code here. So suppose our movie is, okay, let's just say that the title of the movie that we are looking for similarities for is The Godfather. Okay, so I'm thinking about The Godfather, and I want to see what other movies are like The Godfather. So the first thing we need to do is we want to find out what is the index of this movie, the specific movie Godfather itself. So in order for that, we have to create two sets. So we have to create a set called titles, which is all the titles. Okay, so let's see what these titles look like. Okay, so it's all of these titles, and then we want to create here. Okay, so this is the title we were looking for, and then now we created something called titles. So we want to go in here, find Godfather, and then get me the index, right? So that means we need to have a list of all of these indices also. So indices is a series, and I want to take it from dfmovies.index because I want to know what this list is, and then I want to just switch index so that if I give an index, I want to get the movie, right? So df movies. So if we do this, and let's see what indices look like. So in indices, if I give it an index, if I give it a movie, I can get the index. So this is just, the same array, just one giving the other, right? So titles gives you, if I give the index, I get the title. The indices, if I give the title, I get the index. Okay, I just need these for my calculations. Okay, so now that I have the title, the first thing is I need to remember what the index is. So indices, and I'm going to pass in title, right? So if I do that, then what do I get as the index? Okay, so Godfather index is 834. Okay, so now I want to get all the similarity scores for the movie Godfather for the one with index of 834. So I'm going to get cosine sim with index 834. That will give me all of them. Okay, so let's see this. Scores. Oh, I didn't calculate this yet. Okay, once we run this, we can proceed to do this. Let's anyway write the code here. So this would give me all the entire list of scores. Actually, you know what? Let's continue down this once this is run. So let's let the cosine similarity run. Okay. So while that's running, let's go ahead and talk a little bit more about the other type of filtering, which is the collaborative filtering, right? So for collaborative filtering, like we said, we are looking for commonality between people, right? And so let's see how we would go about, or how does that even work? What are we looking at commonality between people, and how do we calculate that? So I'm gonna go down here. Okay. All right. So say we have collaborative filtering. By the way, since this is a master class, which is why we're going through this very quickly, there are on campus, usually these topics are talked about for weeks. Okay, so suppose we have a data set that's like this. Now remember, for collaborative filtering, we just need to know what somebody rated for each item. It's all about ratings, right? It's all about whether they liked something or not. So suppose, but going back to movies, suppose we have movies, we have The Matrix. I have another movie called Alien, and then Serenity, and then two more, Casablanca and Movie. Okay, so we have these 5 movies, and we have some ratings. So we have user 1, user 2, all the way to user 7. Okay, so you've got 7 users and 5 movies. Okay, so it's a 7 by 5 matrix, and this is a movie full of ratings. So user 1 gave a rating of 1 to Matrix, and they also gave a rating of 1 to Alien and 1 to Serenity, and 0 means didn't even, either didn't like it or didn't watch it. User 2 gave scores of 3, and user 3 gave scores of 4, and this user gave scores of 5. And then this user gave a score of 2, but then this user gave higher scores for the last 2 movies. This user didn't watch any of these or just give very high scores for this. And then finally you have this one user. So by looking at this, what we are sort of seeing, right? So you've got user 2, 3, 4, 5, 6, and 7. So what does it look like? It looks like users 1 through 4, kind of like these movies here, Matrix, Alien, and Serenity. And then it looks like users 5, 6, and 7 kind of like the movies down here. And then there's, of course, a little bit of, this user somehow liked Alien as well. So let's talk math a little bit. So mathematically, any matrix, any m by n matrix can be split into, so any m by n matrix can be split into, converted into an m by u, just some u, times, maybe not, let me not use u here, m by, let's just say, let's call it actually let me use the same thing as I do here. So here we have, it's users times movies, right? You have users times movies is what we have. So this can be converted into a u by c times a c times a c by c times c by m. So I can decompose this u by m into 3 matrices. So this is a decomposition. Okay. And it so happens that there is always a way to break this. So there is always a way to decompose this. And there is also, and it is always unique. It is a unique set of matrices that you can break this into. And this method is known as singular value decomposition, okay, or SVD. So who cares, right? What does that have to do with anything here? Well, and this is the aha moment that happened in the field of data science and AI a few years ago, is if this mathematical phenomenon can be applied here, what does that happen to give us? So if we applied SVD to this is what we get. We end up getting a U by 3, and then we get a 3 by 3. So the value C is 3 here, and then we get a 3 by M, and M is 5, right? Okay, so this decomposition, and if we were to apply this is what we would get. We would get values like, so 0.13, 0.41. I'm just going to show you these values here, 0.68, and then some smaller values, 0.15, 0.07, 0.07. So what you would start to see is that there's a high value. There's a high value for the first row, okay, and there's a high value here. So these values are high. These values are high. So this was negative 0.59, negative 0.73, negative 0.29. Compared to these are very small values. So you'd find very high values here and very high values here. And then, by the way, another interesting thing about this decomposition is the C by C is also a diagonal matrix. Okay, so this value happens to be 12.4, 0.95, and 1.3 with zeros everywhere else. And then finally, here in this matrix, you have high values, 0.56, 0.59, 0.56 here. Not so much on these, and then some higher values here. Okay, so what ended up happening is that the researchers who applied SVD to this found out that there is some meaning to this 3 or the C. And that happened to be that if you look at users 1, 2, 3, 4, and 5, they liked Matrix, they liked Alien, they liked Serenity. It was grouping these right in this way. It was sort of creating this boundary here. Okay, and it's grouping all of these movies basically. Okay, so if we wanted to put a name for these movies, Matrix and Insanity, maybe that would be called sci-fi, maybe. So sci-fi. Okay, and then the movie Casablanca and Emily have been grouped together. So this is the second one here. It's romance, and then you also have another column here for just kind of the noise. Okay, so that's just noise. And then here, this 3 by 3 is, so this is sci-fi to sci-fi, and then you have romance to romance, and then you have noise to noise. And then finally here you have, this is sci-fi, romance, and noise, and the columns here are the, so here it's the movies, right? So you have all the movies here. You have Matrix, you have Alien, and blah, 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 right? So what we ended up finding out is that all the users that, you could say that you could take this one big matrix on the left and break it up into a matrix here that gives you the mapping between users to concepts. And here concepts happen, because it's movies, it happens to be genres of movies. And then down here, you have a mapping between concepts to movies. So which movies fall into which? So it automatically puts Matrix, Alien, and Serenity into one group. It might not know that the name of that is a genre, but it just knows that it is all part of, one group, right? So it automatically puts maps users to concepts, and it maps movies to concepts. And then in the middle here, this gives us the concept strength. Okay, that is in this data set, how strong is the sci-fi and how strong is the romance, right? So the fact that you can take any matrix, any rating matrix like this, and then apply singular value decomposition, which gives you this user to concept strength, and concept movies, helps us figure out which users are similar to each other, right? And it also stores what type of ratings did they give. And so if multiple users are part of this same user concept group, right? So they say, you are a user that shares multiple concepts with this one user, then we are going to recommend another movie from that same concept for you also. Okay, so I'll repeat that again. If you have two users, so let's say I'm a user, I've already said that I've liked Matrix, then it'll say, that means you belong to, you have a high affinity to this sci-fi concept. Here are some of the other people that also have a high affinity with sci-fi concept, and here are some of the other movies that are in there as well. And so, but sometimes this could go across, right? You could have movies in here that you may not have thought of. You have other users have watched it, they have given them high ratings, and they'll say, we think you might also like it. Okay, so again, mathematically, that this is always possible and it's always unique. So you always end up with just one set of matrices like this. That's then we could use. Okay, and I will attach a link to a tutorial video that kind of goes into this specific example more in detail. But so our plan here would be to generate the this singular value decomposition matrix, and then predict what rating would I give to a movie before I even watch it. Okay. All right. So here the cosine. So going back to content-based filtering. The cosine similarity is done here, and now I want to find out what movie is like Godfather. So I apologize for switching gears back again. Just a reminder, we are back here. Okay, so we are back to content-based filtering. We're trying to calculate the similarity, cosine similarity for a specific movie. All right, so if we look at the cosine sim scores for The Godfather, right? Then this is all, but now we need to sort it, and we also need to first of all, we need to also remember, just because we got the scores, we don't want to lose the index of the movies, right? So in addition to getting this, so I want to, if I want to remember the column number, I can do something like this and write. And now you will see, we need to put it into list one. Okay. So now all of the similarity scores, so this is that entire row, right, of movie Godfather. These are all the similarity scores, and we remember which column it was. by adding enumerate, and now we need to sort this to get the top few. Right? So again, I'm not going to write the syntax for this, but I'm going to say sorted. Say sim scores, and sometimes these are called lambda functions. You can, whenever you want to apply some kind of transformation. So here we're trying to sort it, and we want to sort it based on the second value in this list. So the second value here goes as 1, and I want to sort it in reverse. Okay, all right, let's see. All right, once I do this, okay, so this is cool, right? We know that this movie was index number 834, and it has, a value of 1 because it is the same one. And now we have all these others so basically movie number 1176 has the next highest affinity. Movie number 40982 is the next one. So now we need to go clip this somewhere and then try to get the movie IDs for this. So first let's clip it, some scores. We want to ignore the first one, so I'm going to take 1 to, let's say, the top 30. Let's do that. Okay, so now we are seeing, just the top 30, and we see we dropped the first one. So these are the most common movies with respect to the descriptions. And now we want to get the movie indices, the actual. So movie indices is, I want to get the top, this list, just the first column. To do that, I'm going to say for I in sim scores, I want to get this list. I want to get the first column, so I 0 for I in sim scores, and I'll put that as a list of its own. So movie indices now should be only the first column of that. Yeah, you see that? Now we want to return, so we want to get in the titles table, I want to go and get the titles of these indices. So say titles, and because this is the index I'm looking for, I'm going to do the iloc. Again, go and search. So the iloc is kind of like the loc function, but it uses the index instead, and movie indices. Okay. All right. So we see here that The Godfather Part 2, Godfather Trilogy, this is all very similar to The Godfather, and then you get into Blood Tide. And so we've already done what we would have wanted to do, right? Now you can quickly put this into a function, and then you can do this for other movies also. So if we say get recommendations for some title, and this is our function. Let's do that, and then let's return this. And this, okay. So here's our recommendations function. We'll take this out. I don't need this title anymore. Okay, and now we say get recommendations for The Godfather. And just let's get the top 10. This is for Godfather. And if we said no, we want to see it for The Dark Knight, then right away it goes and says, okay, here's the movies that are similar to The Dark Knight. Cool. So we've essentially done content-based filtering. This is purely based on the content. Now to go and apply, so here we've given a movie and we're getting other movies that are very much like purely, and this, but it has nothing to do with what I like, right, and what I have rated in the past. So now let's go ahead and say, okay, the second one here is not content-based filtering, but collaborative filtering. So let's say filtering. Okay, so what did we do for collaborative filtering? We applied singular value decomposition, right? That's what we wanted to do. So we need to load this matrix. We already have it as a data frame, and we need to apply SVD. Okay. So by the way, there is a very good library for SVD. There are actually many libraries for SVD, but I would recommend this library. So let's say that it's Python surprise SVD. Okay, so this is the library that I would recommend, and the documentation of that is here. And why I like it is that, you know, SVD is a mathematical function. If you try to use math libraries for it, you're going to be doing a lot of extra work. This surprise is a library that has SVD, but it's written a little more code to fit very well with, like, you can do cross-validation, you can do, you know, train test split and things like that to be able to do that. Okay, so let us go and see what we can okay. So first we need to load the data. So by the way, to install Surprise, you're going to need to do something like this: pip install scikit Surprise. Okay, you're going to have to do run that to install it, and I've already installed it, so I'm not going to do that. But so after that, let us. Okay, so from Surprise, first we need to load the data. So we're going to do. Okay, we're going to take it up to here. We already have our ratings. So if you remember DF movies, right? Let's add that so we remember DF. So this is what we have. We have user ID, movie ID, and rating. That's what we're going to be using. So here you see item ID, user ID, rating, but we'll use our own. We already have our data frame. So first thing we need to do is we need to define something called a reader. This is just how the surprise library works. So we're gonna kind of form fit it a little bit. And then our data, we're gonna load it from a data frame, and our data frame is df df movies rating. And we are going to be giving user ID. Ours is movie ID and rating. Okay, reader. And we're going to set this as our X data set. And so you see how in Surprise you have to give it in the order. First you got to give user, then you have to give the item, then you have to give the rating. So that's why we adjusted it. And here we already have our data, so we don't need this. Okay, so we're reading this data and we're putting it into the form. And you know what, we can also do the train test split because they have the ability to do that. We want to test the rating prediction before we actually apply it. So let us also do the train test split. Let's look for some code here for that. Here, train test split. And sorry, okay, train test split. And then you do SVD here. Okay, let's just do the train test split and then we'll do the SVD part. Okay. Got train test split. Let us okay. So X train, going back to some of our previous naming convention, train test split X, and let's leave the test size as 0.25 here. Okay, this. Okay, all right, so this should give us, this should set up the data for SVD, and then now let us go for SVD, okay. Now we're going to actually go, so this is the define step, right? If you remember in our methodology, this is the define, and now we're going to do a fit and predict. So here's the from surprise import SVD, and then we're going to do, here's the SVD, and then fit and predict. Okay, and then we can also just look at the accuracy scores. Okay, let's do that. And this is you're trying to fit and predict SVD. Okay, here, so it says from surprise for SVD. All right, and that's in the L, let's call this SVD for movies and the ratings. I'm going to say model.fit with our X train, and then this is our model dot. So it uses the test, it uses a test function to do the predict, so we'll just use test here, but later on we can still use predict, and this is our prediction again. So our target is kind of the ratings column here, right? Okay, and we want to test the accuracy of these predictions. So while, let's see. Did we accept something here? So we did the, oh, accuracy, we didn't define accuracy. From surprise import accuracy, okay, there you go, accuracy, we didn't do that. I know we're running a few minutes late here, but let's just wrap this up. Okay, so we've applied SVD now, and we've gotten decent accuracy for this model. Again, so this is kind of, you know, it looks like regression, but this is actually applying SVD, and then it's doing separating out part of the data, you know, making the predictions based on that, applying it, and then comparing it to the result. So we can actually, they even have cross-validation. Since we already know cross-validation, we can even maybe add that piece here. Okay, so there is cross-validate from surprise model selection, cross-validate. Let's see if we have a clean example here. Okay, here. Let's do cross-validate. Okay, cross-validate, and bifold cross-validation. This is our model, and we're going to give us the full X now. Remember, whenever we cross-validate, we give the full data set because it can do the splitting on its own. The measures, what do we want to do the cross-validation against? Our MSE and error, maybe 5 splits. Okay, so this might take a little bit of time because it's going to do this 5 times. So let's kind of, you know, quickly recap. But once this is done, we still need to do a little bit of post-processing to figure out, okay, for a specific user, what would you suggest, right? So quickly to recap, we started off with an overview of the different types of recommender systems. We said that if the first time somebody comes in, they might be interested in something, we would use content risk because we don't know any. They haven't put anything in their cart yet. They haven't rated anything yet. If they put something in the cart, we can give them some bundling recommendations. If they have already purchased something in the past, then we can give them some not even related items. These are very different items. Okay, so for example, so here, cross-validation is done. We've gotten decently high scores in all the folds. So we would say, yeah, that's good to go. So now let us predict for a user that has not watched a movie. So let's see what. Let's take a look at user 1. Okay, so let's say user ID is 1. Let's see what movies. Oh, so this is just a Boolean, it just says if the users. Let's see what ratings this user gave for the movies that they watched. Okay, so user ID 1 has watched all of these movies and they've given these ratings. Now, based on the SVD, we want to see if they watch, for another movie, what rating do we predict they would give, right? This is based on SVD. So let's say that there's another movie number, I don't know, say 300 or 302, for example. We want to see what would that user give for that movie. So let's say they have not watched it, right? So rating, let's predict, and then here this goes as user ID and movie ID. Okay, so this 302 is another movie, but this user hasn't watched it. What would this user give that movie? So user ID 1 for movie 3 would give us a rating of 2.63. Right. So you can imagine that as if I'm user 1, then all these other movies that I haven't watched before, we can predict what the ratings I would give for them, and then again write functions like we did before to find the ones that have the highest ones, the highest ratings that I might give, and then recommend those to me. Okay, so before we close out here, I want to show you one example of, so if we were to go to Amazon and, all right, so Thanksgiving is coming up. Let's see, suppose I wanted to buy a turkey fryer. Okay, and okay, let me say I want to buy a turkey fryer. Let's see, I just want only the right, let's go with this. Okay, so so you see that as I scroll down here, so I'm searching for this. I haven't bought it yet, right? So, but this is kind of assuming that, okay, suppose you bought it, suppose you had put this in the cart, then this is something else that is frequently bought together. So this is the bundling recommendation, right? Remember, going back here, this is this recommendation, right? So if you were to buy this, if you put this in the cart, you might want to put these as well. And so this is that bundling recommendation. Then if you go down, you see this products related to this item. These are items that have very similar descriptions, right? So other items, so you see it's giving you a different type of fryer and a different way of frying and all of that stuff. So this is the content-based filtering, okay? And then if we were to go further down, sometimes it will also give you, oh, here. So this is product related to this item. Oh, see, customers who bought this item also bought. So other people who bought this item, who like this item, happen to buy some other things. See, look, turkey seasoning, that has nothing to do with at that time, or a prior cookbook, right? So, and sometimes you'll find very random items in this list that had nothing to do with this. And so this customer who also bought this item is this one, right? Which is collaborative. So I call this out because when you go out there, you would hear people saying, "Oh yeah, it's like the Amazon recommendations," and they kind of merge all of this and mix up all of this. And what you really need to find out is, depending on the type of data you have, you're going to only be able to do. So when do you pick what? Suppose it is a cold start problem. You don't have any data. Okay, without any data, you can still do content-based filtering, right? Because as long as you have all the descriptions of all the items, then immediately you can do, if somebody's interested in this, you can give them other items like that. This is without knowing anything else. So this is the most common one. Okay, this is using TF-IDF. Now, if you also have transactional data, you have historical transaction data like we did last time, then, and that somebody had, what others have bought together in the past, what they have purchased together. If you have that data, then you can do bundling recommendations. Okay, and this is sometimes the most hardest to get data for, because you need to be part of that system. Amazon's not going to give you this data. Okay, nobody will give you this transaction data unless you work for that company. But let's say that you don't know if they purchased anything or not, but you know that they like something. They have shown you that they actually like something, and you have that data from others. You have ratings data. Then you'd also be able to do this collaborative filtering. And this is the area that is growing very fast, the collaborative filtering. And there's many, like SVD, there are many other methods to do this. And, it's sometimes also called inferential learning. You infer relationships between things that are seemingly unrelated. All right. So with that, let us close it out for today.